isn't this one n equals 0? And isn't this one n equal 1? And isn't this one n equal 2? And you get the idea, right? Now, what do you do? What do you do with those numbers in the sequence? What do you do with them? There's a one-word answer. What do you do with them? Not add them. I'm not ready to add them. That's the series when you add them. What do you do with them? What do you do with them? Nothing.
You see there's a pattern? You look for a pattern in this?
Yeah, but remember, I just said it's a bunch of numbers. So it could, William, it could be the game where you tell, you got 5 of your friends with you and you say, okay guys, give me a number between 1 and 10. And so you'd list 5 numbers in no order, no nothing. That's the sequence. What I'm telling you is you do nothing. You do nothing. Okay? Whereas with a series, the difference between a series and a sequence is, with a series, the commas are replaced by plus signs. Okay? But don't even think about that just yet. All right? But then that leads me to I'm going to start with Seth, and I'm going to go around the room, and you give me terms. Seth, we're going to start at n equals 0. So what's the first? What is the first one? 1. Travis? 3. Josh?
5.
5.
7.
What? I just didn't hear you.
7.
7?
9.
11.
Get the idea? That's that pattern that William asked me about a minute ago, right? Okay? Did I do that right? If I start at 0, minus 1 to the 0 is 1, right? So that I would just use the first term. But minus 1 to the 1 is minus 1. So do you follow what I'm doing? So everybody get the idea? Couldn't I have that? If n is 0, doesn't that make that 0? So isn't that 0? If n is 2, the sign of pi is... Oh, I got to get n equal 1, I'm sorry. If n is 1, sine of pi over 2 is 1. If n is 2, isn't it 0 again? If n is 3, isn't it negative 1? And then it starts repeating. Get the idea of how to build a sequence? All of our sequences, no, not all of them. This one is called monotonic. Monotonic means that it is never increasing or never decreasing. It means it's always increasing or the same, or always decreasing or the same. Monotonic. It's either always going up or staying the same, or always going down and staying the same. How about this one? And this one's going to have to start at 1, isn't it? Isn't that monotonically decreasing? It means that every term to the right is less than or equal to than the one to the left. Okay? Okay? Everybody? All right. I never cover things like the book, so let me see how much I covered. See if I left anything out. That's the way we write a sequence. We write A sub n, meaning a sequence of A's starting at 1. Okay? That sequence converges if the limit as n approaches infinity of A sub n, which is equal to, let me see the way they do it. I got to look at their notation again.
Infinity.
Which is the same as is equal to a if it exists. If I can take the limit of the nth term of a sequence, and that means what I use to form the sequence, and get a number, then the sequence converges. Okay? And what they they say is, they use this all the time. I don't particularly like it, but that era means approaching infinity, okay? So watch as we do a problem. This is example 1 on page 552. No, I'm not going to do number 1. Too easy. Too easy. This is example 3 on page 554. I want to know, this is A, I want to know, does A sub n equal to minus 1 over n converge or diverge? And if it converges, what does it converge to? How do I determine that? What did I say? Give me one word that describes what I do next. Limit. Limit. Good. So what I do is I take the limit as n approaches infinity of a sub n, which is equal to the limit as n approaches infinity of minus 1 over n, which is equal to minus the limit as n approaches infinity of 1 over n, which is equal to. How did I know I could pull that negative right there out front? I gave you two. It's a 2-word answer for everybody but William. Still a 2-word answer, but it's a different answer than you two, I guess, Josh. Ms. Hardy. For those of you that had Ms. Hardy for Cal 1, didn't you learn in Cal 1 that if you have a constant inside the limit, you can just pull it out front? What I'm telling you is I'm not showing you anything new. You've seen that, haven't you? If you're taking the limit of 3x, that's the same thing as 3 times the limit of x. And in this case, instead of 3, it's negative 1. But then you also know that the limit as n approaches infinity of 1 over n, it turns out to be minus 1 over infinity, right? Which is equal to minus 0, which is 0. And I wouldn't have begun to write all of that if I were doing this problem. I would have written the problem down, then I would have gone to this step, and then I would have gone to that step, and then I would have gone to that step. So don't think you have to put all that in there. I did that so you'd understand what I was thinking. Shall I say, I'd like to see this step, I'd like to see that, and I'd like to see that. And if you want to put it all, fine. I was just trying to show you what I was thinking. 3B.
So that one converges.
That's right. Thank you. William, I need to say that. A sub n converges to 0. Okay? Questions? Let me show you what a convergent series looks like. Aren't you used to seeing that? Yes or no? Okay? If n is equal to 1, a sub n is minus 1. If n is equal to 2, a sub n is minus 1/2. If n is equal to 3, a sub n is minus 1/3. If n is equal to 4, a sub n is minus 1/4. If n is equal to 5, a sub n is minus 1/5. If n is equal to 8, that's equal to minus 1/8. And 10 is minus 1/10, and it keeps on going, doesn't it? Everybody agree? So I'm going to plot those points. Follow what I'm doing? And I'm going to tell you that that point right there is the point 0, 1. And over here, on the x-axis, they're just 1 each. So, at 1, I get 1 and minus 1. So there is that point, right? Then I get 2 and minus 1/2. 1, 2, 3, 4, 5, right there. Then I get 3 and minus 1/3. So I go 1, 2, 3, and a little bit more. Isn't that 3.33? Or 0.33? Then at 4, I get 2.5. And at 5, I get 2. At 8, I get 8 is 1, 2, 5. 5, 6, 7, 8, 1, 2, 5 is about there. At 10, I get right there. So can't you see where that line is headed? And as n gets bigger, don't you expect it to get like that? And that's what we're saying. That's what we were saying up here when I had minus 0. Instead of that minus 0, wouldn't I say 0 from below? Okay? So do you follow what convergence is?
You're saying 0, but you would put the negative sign over there where you
Where
used to put
is
it.
that notation from?
What? This? My students that have had chemistry, I guess, Ed, the charge, isn't that where the charge goes? So we jokingly call it the charge. What that 0 up there in in the upper right means it is approaching zero through negative numbers, or approaching zero from below. That's what it means. That tells you, it's only used with limits, and it tells you the direction that it's coming from to get to zero. But in our case, it doesn't matter, does it? We just wanted to know that it approached zero. But now that we've graphed it, you get an idea of what I meant by that negative zero when I wrote it. Ed?
You'll let it figure out what the nth root of n is as n goes to infinity.
Yeah.
Because that's going to come up.
Yeah, it is. And that's one of them we're going to do. We're going to get to it. Questions, anybody? I need to quit for the day.
Sounds like e to the x.
It is.
Is it?
You use logs to do it. So you can pull the n out front. Very good. Questions? Okay. Test is Tuesday and Wednesday.
Wednesday.
Yeah, that's what I thought. After I looked at those homework grades last night, I thought it might be Wednesday. Let me talk to my travelers for a minute.
If you could